Consider a curve in the first quadrant where everything is positive. The tangent at any point P cuts the x-axis at Q. Given that OP, so O being the origin, OP equals PQ. Remember, Q is the place where it cuts the x-axis, where O is the origin, and that the point 1, 4 lies on the curve. Find the equation of the curve. So this point 1, 4, this is the initial value. So that's what enables us to turn a general solution into a particular solution. So they're the initial values. Okay, so for the rest of it, we're going to need some kind of picture. Okay, we can draw our first quadrant. So you've got nice x-axis, y-axis, and we know we're somewhere in the first quadrant. Right? So we need to pick a point, and then you've got a tangent that basically needs to be the same. So it could be the point P at x, y, and then you need to go to O. So basically this line here needs to be exactly the same length as the line to the x-axis, right? So it's going to, effectively, it's going to look like that, right? So this is a point Q. And this line here, we know is a tangent. So this is the tangent at any point P cuts the x-axis at Q. So this can now extend to be a tangent. So if you kind of draw a curve where the tangent kind of looks like that, it's going to be quite steep here. And if you look at the rest of it, we're just going to now keep the curve kind of doing something like this. So it's not the best diagram in the world, but hopefully it's good enough to get an idea. Now it says that they're the same length. We've just used that to construct the diagram. So they are exactly the same length, which means we've just formed an isosceles triangle, OPQ. If you have an isosceles triangle, then you can drop perpendiculars like that. You can drop bisectors, which make right angles, which are very useful, right? So if we call this, we'll just call this kind of M. And if you think of the coordinates of M, well, it shares the same x coordinate as P, so that's just x, and it's got a y coordinate of 0. Okay, so if M is x along on the x-axis, this distance here, so OM, must be x, and because of the type of triangle we're dealing with, MQ is also x, like this. So you've got x and x, and then you can use that to deduce the coordinates of Q. So Q is going to be at 2x and 0. Okay, so now we need to think differential equations. So you might be thinking, where on earth would I get a differential equation? Well, this is all about gradient. Tangents are about gradients. They have, where it meets the curve at this point P, it has exactly the same value of dy by dx at that point. So at point P, the gradient of the curve dy by dx equals the gradient of the tangent. Okay, so we can write dy by dx equals, and then we can think, well, how else could we get the gradient of this curve? So if you use this triangle, you could use y step over x step. Okay, write that down, y step over x step. Okay, you can see that it is a negative gradient, and you know that it goes at x across here. So this x step is definitely x. Think of the x step as always being positive. And the y step, well, it's gone down from y, it's gone down to 0, so it's minus y. So that is an algebraic expression for the gradient of the tangent. And it's great because it takes into account the fact that it's negative. So our differential equation is at the point P, dy by dx equals minus y over x. And I say at the point P, don't forget, P is a general point. Look, it says at any point P, so it's not just like picked at one point. If we move this around, this situation isn't going to change. It's a property of the graph. So now we've got our differential equation, we can proceed to a general solution. So we want the y with the dy by dx. I'm going to leave the minus sign over there. So divide through by y, that would say 1 over y dy by dx equals minus 1 over x. Now we can integrate both sides with respect to x. So that would be the integral of 1 over y dy by dx. Well, it's the equals the integral of minus 1 over x dx, so I can write that as minus the integral of 1 over x. 1 over x dx, just like that. So these are very friendly integrals, but just before we do that, have a look at these dx's. Dx, 1, 1. So you have the integral of 1 over y dy, integral of 1 over y dy equals minus the integral of 1 over x dx. So these are very nice integrals. It's ln of the absolute value of y equals minus ln of the absolute value of x plus c. So ln absolute value of y equals minus ln absolute value of x plus c. So now it's awkward to know where to go, but if we want to undo that log, because we're looking for the equation of the curve, right? So we're looking for a nice relation between x and y. Find the equation of the curve. So we want to try and get rid of these ln's if we can. So let us combine the ln x and the ln y, and then we can use a log law on that. So ln of the absolute value of y plus ln of the absolute value of x equals c. And by the way, I keep talking about absolute values, but we know that this is all in the first quadrant anyway, so you don't need to worry too much about that. So ln xy equals c. Okay, so undoing that, hopefully you've seen enough of these by now to know it's just going to be xy equals e to the c, but I will just show another step anyway. So we're undoing the log by raising e to the power of both sides. So e to the power of ln xy equals e to the power c. Okay, so think of what ln xy is. It means the power that you raise e to get xy. So if we raise e to that power, we're just going to get xy. So xy equals e to the c. Okay, if you think about e to the c, well, it's just a constant. C is just a constant, so e to the c is also just a constant. So we're going to say let big A equal e to the c. It's just going to make things a lot easier to deal with. It's just a constant. Right, so that means that xy equals some constant a is the general equation of curve. So once you've got the general solution, you can now use these initial values to find a particular solution. So we know that the curve passes through 1, 4. Okay, so the curve passes through 1, 4. So basically 1 times 4 equals a, which means that a equals 4. So if a equals 4, the equation of the curve now is xy equals 4, and we can rearrange that very simply into y equals 4 over x. So y equals 4 over x is the equation of the curve. Okay, and that one's finished.